so now we've explained that a thermistor is a device whose resistance varies with temperature. And as the temperature goes up, the resistance goes down. Okay? Now, we need to use that in order to be able to measure temperature when our CANSAT is in the air. So we're going to have a thermistor that is ultimately going to stick out of our can, and it is going to be able to connect up with an Arduino, and the Arduino will be able to send the information back to our laptop, and we will know and be able to track what is happening to the temperature as the can is falling. Okay, this is the can. Okay, so the next bit we need to talk about is how are we going to do that? Okay, so effectively what we're going to do is we're going to connect an ordinary resistance. I can't remember what it is now. We'll just say it's a 10 kilo ohm resistance, but it makes no difference to the explanation. And we have our thermistor. Okay, now our thermistor has a certain resistance. We'll call it RT. This is 0 volts, connected to 0 volts. This bit up here is connected to 5 volts. And we are going to connect the point here to an input on our Arduino called A0. The 5 volts is actually also going to come from a 5 volt output on our Arduino, and the 0 volts output on our Arduino will drive the 0 volts here. So what we do now is, or how this works, is the thermistor will be exposed to different temperatures. Its resistance will vary according to those temperatures, and because the voltage across something, V, is equal to I times R, then this voltage here, because this is 0, so the voltage across this thermistor, which is what's going into the input A0, that voltage will depend on the temperature of the thermistor. Okay, now just a very brief rundown on this. There's 5 volts here, there's 0 volts here. So between here and here, we have 5 volts. That means 5 volts across here and here. And remember, V is equal to the current times the resistance. So in this case, 5 is equal to the current times, now what is the resistance in total between here and here? It is going to be the resistance of the thermistor plus the 10K. That's also a measure of resistance. So our current that's flowing down here through this entire thing, I, is equal to 5 divided by RT plus 10. Now if that's the I, then the voltage here, this V, VO is equal to I times RT, current times this resistance. So VO is I times RT over, instead of I, we're going to put in 5 divided by RT plus 10. That's not that important, other than you can see that the resistance of the thermistor is what affects the output voltage. Okay, and actually even if you take it from here, rather than confuse the issue, that output voltage depends on this resistance. If this resistance of the thermistor goes up, then the output voltage will go up also, because they are, if the V out is this number times this, then as this number goes up, this number will go up. Now, remember what we said. What makes a thermistor go up is the temperature going down. So what we're really saying there is, if the temperature goes down, the resistance goes up and the voltage goes up. So think about that. Temperature decreases. That means that the output voltage increases. Just to explain that again quickly, if the temperature, sorry, that's my phone, if the temperature decreases, the resistance of the thermistor gets bigger, and if this gets bigger, this number will get bigger. If the temperature increases, then an increasing temperature will reduce the thermistor's resistance, as explained in the previous video, and that will cause the output voltage to decrease. So one important thing that I would like you to remember is that an increase in temperature is going to give you a voltage that will decrease here, and a decrease in temperature will cause this voltage to increase. Okay? Now, I will next discuss how we program our Arduino to deal with that and to convert that output voltage back into a temperature that it can report on the screen so we can monitor the temperature.